Good morning, one and all present here. Myself, Soumya, here to present the paper which we have worked as a team consisting of Brinda, myself, Soumya, Akarsha, Manjunath, Nikshep, Samuel Roshan Kumar, and Nijaguna, all from the Nitte Meenakshi Institute of Technology, Department of ISE, Bangalore. So here I am here to present the topic or the paper that we have worked on, which is the classification of Devanagari characters using deep learning methods here. So now if we try to understand that this particular topic which we are supposed to be understanding, let's first try to see what are the steps or what are the things that we have to see in order to understand what is the complete essence or what is my paper consisting of. So let me try to tell you the contents that I will be delivering today so that you will be in a position to understand as how the flow of the entire topic has been covered till today. So first and foremost, we definitely have to require this particular motivation as what made us to take up this particular work, later which we need to know the related work which is there for this particular one, and then what are the issues from the literature review or the related work which has been there, what is that we have found out as issues and how are we going to address that issue by creating our own architecture, and then to brief about what are the things that we used as a part of the technology, and finally we will try to understand this particular result and analysis where as how we have experimented, what are the different things that we have studied so far, and then we will try to understand more about, and we are trying to see the last part of it, which is the actual conclusion, or you can see to it that it is the conclusion or the inference of the entire work that we have carried out. So now let's move on to our actual content of it, wherein what is this particular motivation, or rather I would try to tell you that what made us take up this particular project, or what made us take up this particular work which we are trying to publish as our particular work. So now if we try to understand in general what are the things that has been there in this particular study, we are now trying to understand that, say now if we are trying to have a signature or something which has been written in our hand, the general handwriting, say if we can try to tell that it could be a child's handwriting, it could be a student's handwriting, it could be a professional, or it could be rather more or less the so-called the doctor's handwriting, not to talk anything ill about it, rather we all know that there is this particular prescription which has always been given by the doctors where we'll not be able to understand it that easily, or we have a notation or the notion that only a pharmacist will be able to read the handwriting which has been written through this particular doctor. So which means what is that we are trying to understand is any particular handwritten particular thing which is that we are trying to see, it is actually a difficult task for us to identify what has been written in that. So now if you try to tell that the handwritten one or whatever has been handwritten itself is going to pose a challenge, now what do we try to understand with this term called as the Devanagari script? We know this Devanagari script has been there from a quite a long time, and we are still in the process of understanding, identifying what each character is meaning. That is the same thing what motivated us for us to take up this particular work, where we are trying to tell or we are trying to pose it as our work, telling it as the entire set. We have to try to identify what each one of it is meaning. So now if you try to see this, the Devanagari script or the Devanagari dataset that we have taken over here, you try to see this particular one, ya, ya, ma, all these things basically are more or less looking like the similar one. Here we know English or Sanskrit, we know this Hindi or Sanskrit, so we are in a position to tell that this particular word, this particular letter means this. But we try to see this, see all of this here, all of these more or less are looking one and or looking more or less the same. So for this instance is why we need to understand or we need to see what is the classification or how is it being identified over here. So for that instance, we are trying to take up this particular Devanagari script over here, wherein we are trying to have a better accuracy in classifying the characters over here. So for that, what is that we are trying to see is, if you are trying to see this, as I told, being a handwritten, a normal handwritten, where earlier times we used this handwritten for any part of the communication, we did have it as a risk. But now if you are trying to go back and understand this particular one, where you are trying to tell it as the Devanagari characters over here, it is going to be, or it is going to be a very tedious task in identifying or recognizing what characters are, or it is trying to tell you that what set of group does it belong to. So for this, what is that we are trying to pose up is, now that we know this deep learning has become a boom in the industry now, where we are trying to see more or less machine learning or the deep learning algorithms or AI related ones, where we need to understand that this particular domain could give us some insight so that we can try to identify and classify it as this particular so and so groups. So for this, what is that we are trying to have is, we are trying to make use of the deep convolutional neural network. Here henceforth we'll be calling it as DCNN. So this is the one that we are trying to primarily have it over here. The next thing that we are supposed to understand over here is that, why did we choose this? This is the reason why we chose it, to get it as the distinct features of each of these characters in the Devanagari characters dataset. And this is going to be a challenging task for any of us to have the whatever you call it as, the recognition problem over here. So now if we are trying to see this, this is what motivated us to take up this particular work over here. So the next thing that we are supposed to be understanding is to understand what are the related work which is being there in this, so that there is some work which is being ongoing and what is it different from what we are trying to do. That is what we are trying to pose over here. So basically the first set of work, or basically the first work was done by Ashok Kumar Pant and his group, which they tried to actually work on the image data set of the Devanagari script, wherein it was consisting of 92,000 images of 46 different classes. As I told you, we are trying to group it into different set of categories of data, which is where we are trying to have it as the first work over here. The next ones, where you can try to see that it is the work where it is called as the review of research on Devanagari character recognition, which was by Vikas Dongre, wherein in this particular paper they studied and investigated on the direction of the Devanagari optical character recognition research, wherein the OCR is the one which we are supposed to be understanding over here. And the next thing that is being there is that there is the paper which has been there, effective techniques for detection, extraction and conversion of Devanagari text, which has been by Gayatri Korbade. And what is that which is being done is, how do you actually extract and how is the conversion done and how is the segmentation which is being done. That is being done over here with the accuracy of 95%. But still we are trying to tell you that which we are trying to put into our work, where we are trying to post that This is much more better where we are trying to compare different architectures in our deep neural network over here. The next one was by Ranjani Kumari, wherein it is a research proposal on the recognition of degraded Devanagari text over here, in which what is that which is being done is the scanned documents was in the digitized form, single column printed text was considered, and then it was being separated as the text and the non-text ones over here. So basically what is that we are going to have it is, it was either from the old textbooks or newspapers or any particular old ones which we try to consider over here. So that is the major thing that has been there for this particular the work which has been there on classification and identification of the Devanagari characters. But if you try to see it, very less work is being done in this particular classification of Devanagari characters with the help of the deep neural networks over here. So that is the reason why we have chosen over here in this particular one. So what is this particular one which we are trying to have it as the architecture of our system over here. The architecture of our system is that wherein we are trying to collect the image. The user is going to collect the image, store the image, and in this is where you are trying to create a test data and the train data. It could be generally which is of the form 80-20, but we can also try to have it as 70-30 as well. But the ideal ones which we try to choose it as the 80-20% over here. And finally it is being given to the machine learning, that is it has been mentioned as the ones wherein which we are trying to construct the model, extract its particular features, train that particular model, and then we are going to validate the result. Finally, we are going to generate the report, that is how is it being classified. So once this is done, we are going to save that model, what was the actual weights which we tried to give it. That is only if we are getting a better accuracy we are going to save the model. Otherwise we are going to exclusively train it n number of times so that it gives the accurate result. So finally what is that we are going to have it is, once we know that the model has been trained, we are going to give a test data wherein it has to ideally predict what type of data it is. And finally what is that you are going to get as the output image over here as a part of the result over here. So once we have seen the architecture, the same thing which has been there, what has it been done is being written in this particular slide, where we are going to consider it as the 80-20 percentage, and how is the model being trained, that has been mentioned over here. So in order to come to the technologies which is being used, we know that we are going to make use of the deep neural networks over here. So here, what are the different things, different architectures that we try to use is, we have, for now we have taken the consideration of the AlexNet and the GoogleNet. For our further reference, we are trying to take it into consideration the DenseNet, the ResNet, the VGGNet and the other things, so that we can try to have a better comparison. So we are in a position to have an understanding about different architectures giving different results with different changing the hyperparameters or hyper tuning of the parameters. We can try to achieve a better more results with different set of architectures. For now, what is that we have considered is the comparison of the results between the AlexNet and the GoogleNet over here. As we know, what is the AlexNet that we have as? It is that it has been used to it is designed to handle a large, basically a colored image which is of the dimension 224 cross 224 cross 3, and then it is going to approximately support us 62 million trainable parameters over here, which we have already seen it, which we know it. And coming to this particular GoogleNet as well, what is that we are trying to have it is, which we actually had it as the inception model, which is now being referred as the GoogleNet over here. So what is that we are trying to see is, if we do not try to put in, as we have seen a number of different cases when we were trying to implement our results, what did we try to see is, AlexNet did work fine with changing of the parameters and the changing of the epochs and whatever the things that we are supposed to be doing it. But when it came to this particular one, the GoogleNet, what happened is when we try to change the parameters or hypertune the parameters, overfitting was the one which we tried to have it as the concern over here. So for this, what is that we are trying to see across is to have the GoogleNet architecture basically is used to have allowing large number of data with various different sizes over here, and also what is that we are trying to see is wide range of data will be considered on this. So coming to this particular one where we have the our actual experimentation and the one where we are trying to have it over here, what is that we are trying to see is that we try to see as I told you, we have experimented the data set, the Devanagari handwritten character data set, that is the DHCD, Devanagari handwritten character data set, is being used for obtaining and evaluating the results for the ones which we are trying to tell it using the AlexNet and the GoogleNet architectures over here. For with the current state of art architecture of the neural networks, wherein which we have is the 4 layers one for the architecture, I mean the AlexNet, and the GoogleNet is going to have the 8 layers. So finally, when we came to an understanding, what is that we saw is that we have this particular one wherein the implementation is going to provide us the higher accuracy than the current state of art for the DHCD particular one. Basically, all the ones which we are trying to have it over there with the deep neural networks which has been considered, we are trying to tell that we have achieved a better result compared to the current state of art which has been there till today. So if you try to see this, say if we try to see this is just the confusion matrix and how is the accuracy being calculated, that is the true positives, true negatives, false positive and false negatives, that has been there as what is that which we are trying to have it, the general notation. If we are trying to create a confusion matrix, how is that we are going to have it, this which we generally know it. And to summarize what we have achieved, so if we trained the AlexNet for 50 epochs with and what did we achieve is 0.99 and a validation accuracy of the 100% if you try to see, because it was for 50 epochs. Say if you can try to, if you are trying to increase it or if you are trying to decrease the number of epochs, it could go in for a underfit or a overfit. But what is that we are trying to see is at this we are trying to see that it is an optimum where we are trying to have it over here. The GoogleNet with just the 4 epochs we are trying to gain an accuracy of 81.96. Both the validation and the one are more or less similar, 81 point some percentage over here. This is the training and the validation accuracy for these over here. So what is that we are trying to see is this is our results at which we have tried to got it, the loss with the accuracy, and for the GoogleNet that we have is the loss with the accuracy over here. If you can try to see, we have achieved a very good ones for the AlexNet and the GoogleNet. So in order to conclude, what is that we are trying to see is that we are trying to have these this particular deep learning different architectures, as I have told you. Either it could be AlexNet or it could be the GoogleNet that we are trying to have it. For our further reference, for our future work, as I told, we are going to include different number of the architectures that has been there for this, and also we are trying to make use that we are not going to get it into any particular 50 epochs, 4 epochs, 8 layers, 4 layers. We are definitely going to have our particular hypertuning of the parameters, so that there is this particular ideal way where we are not going to have 100. Of course, we are trying to see that we are going to achieve the best result as our future enhancement for this particular work. It is still under process. For us, for now, what is that we are trying to tell us that we have achieved the best state of art when compared with different architect, I mean different things that we have seen the related work. We are at present we are trying to prove that we have got a best result so far for the AlexNet and the GoogleNet. Thank you all so much. We are very thankful to you for giving us the opportunity to present over here. We as a team, Brinda, Soumya, Akarsha, and co-authored by Nikshit, Manjunath, Samuel Roshan, and Nijaguna. We would like to thank you from the Nite Meenakshi Institute for giving us the opportunity to publish paper as well as present it in your esteemed conference. Thank you all. Thank you very much.